All right, so as we continue to work with expressions, we've been writing expressions, in other words, translating them from English sentences to math sentences, and we've been evaluating them by substituting values in for variables. And what we're going to do today is look at expressions and try to determine if expressions that look kind of different are actually equivalent to each other. So let's quickly review the answers to the do now, so you can turn to that page. So these two problems are meant to be an introduction to the idea of equivalent expressions. So although they look kind of different, they're also kind of the same, right? When I multiply them, I still get the same results, but they're in a different order. So they aren't the same, but they are equivalent when you do the multiplication. Same thing when we have variables. If I put any value in for n, I'm going to get the same results. If I put 2 in, I get 2 times 8, and I get 8 times 2. So these are equivalent as well, and we can look at examples by putting any number in for n. So this is just to get you thinking about what equivalent expressions might look like. All right, go ahead and quickly check your homework answers again. For the homework, the last problem was a little tricky, so make sure you understand how I got that answer. When you've done that, you can turn to the next page. On this page, I'd like you to take a look at these 3 problems and decide if the equations that you see are true or false. So go ahead and pause the video and make that determination, and then come back and we'll check your answers and talk about it a little bit. All right, take a look at these answers, and the first one I think is pretty clear that it's true because 8 plus 7 is 15 and 7 plus 8 is 15. The second one, we haven't done too many problems like this, so you want to really look at this carefully. 6 minus 4 is 2, but 4 minus 6 is actually negative 2. And you have to go way back to our number lines, and if you started at 4 and went to the left, the negative direction, because it's minus 6, that would take you to negative 2 on the number line. So this one's false. These are not equivalent. So it kind of works for addition, but it doesn't work when we use subtraction, and that's important to know. And then the last one, you have, it's the same on both sides, except that you're putting parentheses in different places, which means you do it in a different order, but in the end, does it actually matter? And again, if you put different values in for n, you'll find that it doesn't really matter which order you have the parentheses in this situation. So again, these are all examples of equivalent expressions. There's something a little bit different on each side. Well, I'm sorry, these are equivalent, and this is equivalent. This is not equivalent. These are different, but they have the same value. These two are different, and they have the same value. All right, let's talk a little more technically about how we talk about the properties that allow us to have equivalent expressions. So go ahead and turn to the next page. So we have some properties that tell us things we can do with numbers and expressions that make them equivalent. So the first property is called the commutative property of addition. It says to find a sum of multiple add-ins, you can add the numbers in any order. So that means, for example, just like some of the examples we've already looked at, that 2 plus 5 is equal to 5 plus 2. So we can add in any order. Now, an algebraic expression might be something like n plus 5 equals 5 plus n. So that's a commutative property of addition. We also have the same thing for multiplication. To find a product of multiple factors, you can multiply the factors in any order. So that would look something like this. You might have 2 times 3 times 6, and that's going to be equal to 6 times 2 times 3. And an algebraic expression would be something similar. Maybe you have 2 times n times 4, and that would be the same as n times 2 times 4. So that's the commutative property. One way that I remember it is I think of commutative, I think about the word commute. And when I think about the word commute, I think about that's how people move from home to their job. So I think of the word move when I think of the word commute. And that's really what we're doing here, right? We are moving pieces of the expression around into a different order. And we're finding that with addition and multiplication, that doesn't change the value of the expression. All right. So I'd like you to quickly do this first example here. Is n plus 9 plus 2 the same as 9 plus 2 plus n? So pause the video for a second and substitute one value in for n, can be any value, and see what happens. So I'm going to pick something simple like 1. Why make it difficult on myself? So I'm going to do 1, hold on, 1, I keep pressing the wrong button. Okay, here we go. 1 plus 9 plus 2, and I know that's equal to 12. Then I'm going to do 9 plus 2 plus 1. And again, I'm going to get 9 plus 2 is 11, plus 1 is 12. So I changed the order, but I got the same answer. All right, let's talk about this next property, the associative property. So the associative property of addition means changing the grouping of the addends does not change the sum. So this is where parentheses play a role. And we're talking about something like this. I might have, in parentheses, 2 plus 3 plus 4, and that's going to be the same as 2 plus 3 plus 4. So I've just changed the groupings, and it changes the order that you evaluate it because of order of operations, but you will get the same value. Algebraically, again, the same deal. We can have a variable in here, and it won't change the value. All right. Now we also have an associate property of multiplication. Changing the grouping of the factors does not change the product. Again, that means you can multiply in different orders and it won't matter. So that would look something like this. I might have, in parentheses, 2 times 3 times 4, but that will be the same as 2 times 3 times 4. And with an algebraic expression, I might have a variable instead of one of my values, but that's okay. Could be something like that. Now, the way I think of associative is we are associating different numbers together That's how I remember what this property refers to. So here we're associating 2 and 3. Here we're associating 3 and 4. Same thing over here. So associative really has to do with grouping, and that's how I remember that a lot. So I'm going to write the word grouping here. So commutative has to do with moving. Associative has to do with grouping. All right, let's try a couple practice problems. Go ahead and turn to the next page. So go ahead and pause the video and respond to these questions, and then come back and check your answers, and we will see how you did. All right, check out these answers. So this one works. I used the value of m equal to 2, and I got 10 for both sides, so this just supports our commutative property of multiplication because we changed the order. This one, we group them differently. We're dealing with addition, and we get the same answer on both sides. We get 9.5 or 9.5 for both sides, so this was the associative property of addition that holds. But now we're talking about division, and do either of these properties work for division? Well, if I was to try the commutative property, I would do 12 divided by n, and compare that to n divided by 12. So I moved them, right? I changed the order. But if n is equal to 2, for example, 12 divided by 2 is 6, but 2 divided by 12, again, if you put it in a calculator, you're going to get 1.166666, and I rounded it to 0.167. So clearly these are not the same. So that tells you that the commutative property does not work with division. Okay, you just can't change the order. You're not going to get the same answer. Same thing with subtraction. If I change the order, I get 3 and negative 3 if I let n equal 2, for example. So this doesn't work for subtraction either. You just can't change the order. It only works for addition and multiplication. All right, go ahead and turn to the next page. All right, here's a quick little matching exercise, so go ahead and pause the video and take a second to do this, and then come back and see how you did. All right, check out those answers, make sure you got those right, and if there's any time left, you can go ahead and work on the homework, and let me know if you have any questions.